Alright, y'all, so at the end of the last video, I kind of broke down what a box plot looks like, where the elements go, and all that stuff. Let's go ahead and make one right now, just using these numbers. Oh, this is actually our data from our 50 richest people, right? So we're going to make it by hand. And then I'm going to also show you how to get your calculator to make this for you, alright? That's pretty cool. Alright. So again, when I do that, I'm going to put a horizontal axis there.
I'll go by 5.
Huh? You want to go by 5? I think that should work. Let's go. And we'll start at 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. I think that should do the trick.
Yep.
Alright. We have got to give this, what this is, we got to say what this is, right? This is ages. And this is, that we would title this 50 richest people. My title's not really fitting over the top where we would really like to have it. Alright, so, and we said that this was 30, 40, 50, 60, 70, 80, 90. Now we have our proper units in there. It's looking good. Alright, our minimum is 35, so what do? We put a whisker here, right? Quartile 1 is at 54, so we'll go just a little bit less than 55, right? Boom, attach those, okay? So here we go. So I'm going to write down exactly what this is. This is, actually, I can just draw some arrows, right? So here we go. This is that right there. Quartile 1 is right there. Our median is at 65.5, so really close to that line there. Alright, so there's our quartile 2. This is also, we pointed out yesterday, right? That's your median, right? Quartile 3 is at 78, so right around here. So there's quartile 2, or our median, quartile 3. And now our max is at 89, so almost 90, so we'll put another whisker. That is how it should be pronounced, okay? There is an H in there. You say whisker, okay? You say what, or do you say what? You say weather or weather. They're two different things. The weather is what's going on outside. Weather is like whether or not it is. There is a difference. Okay. And there you have it. Now, let's go ahead and get our handy-dandy calculators to do this for us. Alright, here we go. Calculator's ready. So, yesterday we were dealing with this data, this rich data, that had our 50 richest people. You can probably find it on your calculator if you go into recent documents. So you're going to hit home if you don't have it there. And, or sorry, you can hit, recent. And if you saved it as rich, it should be there. If you have a calculator that of someone that didn't save it, that's unfortunate.
I got it.
If you can't find it, I might be able to find it for you. So hit home and 3, and you go to recent. Okay, so we got that. Everyone found it. If you have it, hopefully. I'm gonna have to go to my current document. Here we go. All right. So yesterday we found these one variable statistics for this, right? Now let's make this thing graph a box plot for us. What's happening? Wait. You're almost. Oh, sorry.
My bad.
Okay, so what do we do?
All right, so we're going to hit doc. And we're going to insert the data and statistics page. Remember when you were getting histograms and those frequency plots and stuff like that, right? We're going to get the same type of document. So we're going to insert data and statistics. Anytime you want a graph, that's what you're going to insert. Data and statistics. We got 50 data points there. Okay? We're going to make this x-axis, our horizontal axis, rich. We're going to make it rich. Huh? You got it?
So confusing.
You got it?
Even though I don't have enough.
You got it? Okay. Right. Think so? Yeah. Huh? Okay. All right, and then just make sure that you make the horizontal axis rich. All right? Make it rich like new rappers. Okay. Now we're going to change it. We're going to hit menu. Okay? Menu. Plot type. So before we used to do histogram, dot plot. Now we're going to choose box plot. And there it is. It looks a little bit like what we had there. It's awesome. All right. Let me just show you something real quick. If you use your little pointer, your little mousey thing, you can actually point to each of these points, and it'll tell you what your median is, quartile 3, and all that stuff. Okay. So if you use your little pointer, so if you put in a bunch of data, you don't even have to do that one variable statistics. Like if you're being asked for your min, quartile 1, median, quartile 3, and max, you could just put the data in there, graph it, and then look over here, and it's going to tell you what all those things are. It's kind of cool. That might save you a little time. It's pretty sweet. All right. Plots. We have already used technology to do it because we're awesome. Percentiles and other fractals. So deciles is going to divide things into 10 parts, right? So I think we could do that pretty easily. Percentiles into 100 equal parts, right? So that you could get like whatever percentile, 20th percentile, 13th percentile, whatever you like, okay? So these are fairly self-explanatory. You guys have done these before, okay? It's just they have different names. All right, so we're going to interpret some percentiles. The ages of the 60 richest people are represented in the cumulative frequency graph below. And what percentile is someone who is 66 years old? How should you interpret this? Well, 66 years old. So this is actually called a what? No. Cumulative relative frequency. It's actually called the cumulative relative frequency plus graph. Yeah. Different texts, different names. This is how you interpret this, okay? Someone who is 66 years old, so you're going to go to your age. You're going to find 66 somewhere around, I don't know, that's 62.5. What a weird. I think 66 is probably around here. What percent is that? 50. So that's how you're going to do it. You're going to match the age. You draw a little line, and you'll match it to the percentile. And that's going to tell you what percentile they are. So you would say, how do you interpret that also? What does that mean? if they're at the 50th percentile. So someone who is 66 is at the 50th percentile. How do we interpret that? It means that they are older than 50% of the people in this group. All right? So you say, this person is older than 50% of the people in this group. And that's how you interpret any percentile, right? Like I was saying, like they always give you a percentile with your NWEA scores, right? They used to take a long, long time ago, right? And it'll say, you know, you're at the 40th percentile or 43rd percentile or something like that. That means that of all the people that took this test, you did better than 43% of them. Okay? All right. This thing below is just the answer. All right, we're going to look at a standardized score, okay? So we're going to look at a z-score. What this z-score tells us, okay? It's kind of weird. A z-score tells us how many standard deviations from the mean a particular value in our data set falls. Okay?
Plus or minus the deviation. Is that a good enough thing? Like 2 plus or minus the standard deviation?
I'm not sure. There was like to find. Yeah, it has to do with that. It has to do with the picture that we drew with that 68, 95, 99.7, right? It has to do with a similar picture. I'm going to draw that picture. Not at all. Drawing. So we have a normal curve, okay? This right here is a normal curve. Or you could call it a normal distribution. Okay. Some things about this thing, okay? Some information about this that I think really helps. Oh, this kind of makes sense. And by the way, this is a crappy. That looks skewed, right? It was awful. I just didn't like it because it looked like it was skewed. These things are supposed to be, if I can draw right, perfectly symmetric. Maybe I did better? That's better. So these are supposed to be symmetric. Can't talk. And also, the area underneath them, area under the curve, is 1. Okay? We're going to get into this in much more detail later. But I think if I'm going to draw this thing and introduce it to you, to tell you the 2 most important things about it. It's symmetric, right? The mean is in the center, okay? Remember we used that M thing to represent mean? So if you're going to draw a standard version, right, the mean is 0. The spot where the mean is 0. The first standard deviation, remember we said there was one standard deviation away? That value is 1. One standard deviation away from the mean. Over here we had one standard deviation. Remember when we were looking at that with the empirical rule, that 68, 95, 99.7 rule, right? So we represent one standard deviation on this side as negative 1. And then 2 standard deviations is negative 2. 3 standard deviations away is negative 3. Same thing over here. 2 standard deviations away is 2. And 3 standard deviations away is 3. So, the reason why I draw this picture is because this thing, this formula here, this z equals formula, thus tells us how far away from the mean in terms of standard deviation. So how many standard deviations away from the mean this value, okay? When you calculate this, the mean will be given, standard deviation will be given at this point. You're going to be given an x value, and you just have to interpret what this z means, right? So if I got a z of 1.5, positive 1.5, I would say that that means that whatever value I plugged in there is 1.5 standard deviations above the mean. And we're going to look at an example of that, okay? But that's what this picture, that's what we're doing. We're using this picture. So before, yeah.
I'm wrong.
Yes, it's very wrong. Super wrong. Let's use it. I think it's going to make more sense. So before we had a picture where we actually put the number as the mean, and we had like how many you would add the standard deviations for that. This is what's called a standardized value. So here we go. We're going to find some z-scores. We've got monthly utility bills in the city. We've got a mean of $70 and a standard deviation of $8. We're going to find the z-scores that correspond to utility bills of $60, $71, and $92. Here we go. All right? First thing, we've got some important information in this particular paragraph, I guess. First of all, I see mean of $70. That makes me say that, let's see, it's all the monthly utility bills in the city, right? So do I use X bar or do I use mu? I'm going to use mu, right? Because that is all of them. That represents a population. So mu, my mean, right, is 70. I've got some other interesting information here. I got a standard deviation of 8. And remember, when we have the standard deviation of the population, we use this symbol sigma is 8. And now, that formula that was on the other page, where it said you had a value minus a mean, all of that divided by the standard deviation, I'm going to write it in a different way. I'm going to use these symbols in order to write that, okay? So we're going to say our value is x, our mean is mu, and our standard deviation is sigma. Each one of these things is an x value, okay? That's what we're going to plug in. So now we can plug in all this stuff. So our first problem, our x, we're going to use this 60. We're going to plug that all in here. So x, 60, minus my mean, or mu, 70, divided by my standard deviation, which is 8. What's that going to be? Z is equal to negative 10 over 8. You don't have to do that simplification thing if you don't want to. Just put it in your calculator. These are going to be decimal answers. Almost every time. So, you should get a decimal answer for these. I mean, unless it's like 1, which means it's 1 standard deviation away. This one turns out to be negative 1.25. What does that mean? How do we interpret a z-score? This means that this value of $60 is 1.25 standard deviations below the mean. Because this is negative, it's below the mean. Okay? If it was positive, it would be above. Yes? Yeah. Let's do the next one. So our standard deviation and our mean are the same, right? Standard deviation, mean are the same. What changes? Our x value. We're going to plug this in for our x value instead. So 71 minus 70 divided by 8. What's that going to be? I'm just going to put it in my calculator. 71 minus 70, the entire quantity, divided by 8 is exactly 0.125. So this one is 0.125 standard deviations above the mean. Because it's positive, it's above the mean. Let's get the last one. And then let's compare them. So now our new x value is 92. We're using this as our x value. Minus 70 divided by 8. We'll see what that is. 92. $2.75. So what does that mean? It means that if you had a bill, or that a utility bill that is $92 is 2.75 standard deviations above the mean. Now, an interesting thing to think about. Of each of these 3 z-scores, which one do you think is kind of the most common, or the most average? Think about that picture that I drew, right? Yeah, this one is going to be, so this is going to be the most common. Think about that. Think about the picture that I drew here. Okay? So that one is less than 1 standard deviation from the mean. So it's somewhere in here, right? Any data point that falls in here, 65% of the data is in there, right? We learned from our empirical rule. So I mean, then that means it's probably fairly common, right? Now let's look at the one that's the least common, which is going to be this one right here, right? Or we could say it's kind of an extreme value, right? You wouldn't normally see a lot of bills that are this high, right? And we can relate that to that picture as well. It's 2 3/4 standard deviations, right? 2.3 standard deviations above the mean. Where is that in this picture? It's way over here, right? How much data is over here above this area? It's not much, right? There's a little tiny spot there. So you can look at it in terms of that, right? Where is it in terms of this big old curve, right? It would be really rare to have a bill that's higher than that. And that's kind of where we're headed with this. We have compared. All right, y'all. We did it. Completed. Not just 2.5, but chapter 2 is done and dusted.